Start recording. Hey, and welcome to the next video tutorial for learning design patterns through games. Today we'll be covering the factory pattern, what it's good for, how to use it, what it consists of, and just like a practical implementation. In our example, we're going to be using it to create monsters and minions that another minion spawns, but the nice part about it is it's going to be reusable across the entire game. So if we need to create the minions inside the level and using this method, we can do it there. We can reuse it, or reuse the factory pattern as an example to create items from loot drops from chests or minion kills or anything of that nature. So factory pattern has a lot of uses, can be used a lot of ways. So we'll go ahead and we'll take a look at it. This time we're going to change things up a little bit. Before we would kind of show the code and demonstrate in the process and then show the UML. What we're actually going to do is I'm going to walk you through the UML first, drawing it out by hand, whiteboarding it, explaining as I go, and then from there we will take a look at that and take a look at the and from there we'll take our understanding of the UML, and we'll look at a simple code base of doing it a common way I've seen it done, and then we'll refactor it into the simple factory method, or simple factory method, and then we'll take that even further and then turn it into the actual method or factory method design pattern. So with that being said, let's go ahead, let's get started. We'll take a look at Photoshop here. The first thing that we'll cover is the simple factory. We'll undo that one. So we'll say this will be our simple factory. Basically, the general concept of factories as a whole is they're going to have a product that gets created. So we'll call this our product. We'll have a factory. And then we will have a concrete implementation of that factory. So we'll say concrete factory. Excuse my horrible drawing skills sometimes. And then we will have, and this will be our concrete product. Just right in here. So our product, our concrete product, factory, or concrete factory. Our concrete factory will create concrete products. Basically, our factory will create a product, and then our concrete factory will create the actual concrete product. So if we look at it if we look at it through this eyes, what will basically happen is our code will have, the target layer soon. Our code will have a reference to a factory, and then it will call a create product method. I need to zoom in further or something because handwriting is something awful. So a concrete product or create product method, which will return this product, and so this one will stay the same way. It will return that one. So our code knows a factory. It doesn't necessarily have to know what type of factory it is. It just knows that it's going to get a type of product from it, and then it's going to use its information from this product to do whatever it needs to be done. So if we cover the simple basis of our next layer. So if we cover the simple factory, which I'll actually write up here, It'll look roughly the same. At the top, we'll have some sort of interface or subclass or base class or something of our product. And we will have our concrete factory. And our concrete factory will make like two different products, because basically we will tie into, we'll have some class over here, our game loop, whatever it happens to be. Let's just call this, in our example, it'll be our shaman. Our shaman will we'll have a, let's actually move this down here because this will make more sense. Our shaman will call the concrete factory and say, hey, I need you to create me an object of this type. So this will be concrete 1, or I'm just, for shorthand, I'm just going to call it C product 1. And then on this one, we'll have C product 2. So basically, the concrete factory will know how to create both this product and this product. And both of these products are implementations or subclasses of this product right here. So our shaman basically says, hey, concrete factory, I need you to create me a lowly minion level 1, or a, tank minion number or level 1, or something from that nature. So it'll call its create method, this factory will then decide which one of these it needs to create based on whatever parameters you set, whether it be random or you pass in a string to say, hey, I need this specific type, or whatever the laws for it to actually be. So with our concrete, so basically what this will do is it centralizes all of our code creation into one central point. So when we need to update what gets made, or the rules for how it gets made, we can then we can easily do it in one spot, rather than it's saying an example of before with our shaman, he's going to create a minion that spawns, but we also create minions when the level starts, or when you enter the boss battle, we need minions to get created then. So rather than having to put all of the same constructor or minion creation code in each of those 3 different places, we'll put it in one factory, into our concrete factory, and then just call that. So then when we need to change what happens with that code, say we added a new armor to the game, now all of our guys need to equip armor, we only have to change it in that one spot. We don't have to change it in all 3. So this is simple factory. The simple factory is not actually a design pattern, but I do feel like it's a good thing to cover because a lot of use cases end up only needing something as simple as this. So a lot of the times you'll end up finding that you'll only end up using that simple factory, but it's even though it's not a design pattern, like I said, it's good to cover. So what we'll actually do is we'll take this a step further and we'll abstract it back out. This looks very, very similar to it. This will be the actual, not the Windows button. This will be the actual factory method pattern. So we'll go, so like I said, it'll look very similar. We'll have, I'm just going to shorthand this one now. We'll have product 1, or this will just be our product, which will be as I said before, that'll be an interface or a subclass, whatever, whatever happens to suit your needs better. And here, though, we'll have concrete factory 1. And we'll have concrete factory 2. And both of these will inherit from another class, which will actually be our abstract factory. Let me actually write that out since it's a new concept. Abstract factory. So both of these guys will inherit from this abstract factory. And then these factories will then only create they'll only create products of a certain type. So this will be concrete product 1, and this will be, oops, let's get this done properly. Clean up our lines. So this will be concrete product 2, which both of these will inherit from this product class. And this is technically, these are technically open arrows. So what happens here in our factory method is, instead of looking at our previous one, our shaman would know exactly what this concrete factory is. We'd call it, a minion spawner, enemy spawner, whatever it happens to be. But when we go into our factory method pattern, what ends up happening is we have this abstract factory idea that still creates an object, and passes it back along. But instead of this time, we don't know what type, the shaman then doesn't know what type of object it's necessarily getting. So before, like this one would be, our shaman would have we would specifically call new, let's say, enemy factory. We have our enemy factory class. So we specifically create an enemy factory in here, that is part of our shaman class. Where in this one, what we'll have is our shaman here in this case, I'm gonna write it outside of it. Instead here, it'll have a reference to this abstract factory class. So it just has a reference to an abstract type of abstract factory. And then when it actually needs somebody, it'll just say, hey, create this. And then it doesn't necessarily know what it's getting back. Like we could have it could be, if concrete factory 1, this could be a player factory. And this could be an enemy factory. But either one of these could fit into this shaman class as needed for this abstract factory, because they both inherit from this same subclass. So now, our shaman could accidentally be creating new player heroes, or or maybe it's getting a new enemy. It really just depends on what gets plugged into it. So you can see the leverage here where you can introduce, we covered the strategy pattern a couple weeks ago. So now you can see here how we can then, with the factory pattern, we can combine it kind of with the strategy pattern. We can interchange that functionality for what the shaman's actually creating. So with that covering, we will go ahead and we'll dive into the code for this. And take a look at it inside of Unity. We're going to start with the, let me show you what we've got right here for now. So we'll start with what I commonly see as an implementation for how people create new objects in their code, which is typically very much in line with that type of information and breaks a good handful of basic principles, such as single responsibility. So what we have is here with our shaman, if I press the S key, you see he'll do his cast his magic and he spawns a new minion that comes out of this circle. We can kill him. He makes another one. There's actually multiple types. Let's see if we get a non-random. Nope, we get archers. Archers is the flavor of the day for this shaman, apparently. All right, I know there's actually more than one type coming out. There we go. There's our mini shaman. He's a lot weaker to kill. And then we go back to the matron. This guy really likes archers. That's just his thing. So you can see he's creating an object just fine. if we will dive into this shaman class. So right now, just a simple variable setup. It's the, that little ring effect that's showing, so we can turn that on when it references to all of the prefabs that have to get created, or that the guy can create. A reference to his animator, so we can animate things properly. This is just a local variable, so we know which one to spawn for the timing. So we know when to, show him up, so it's in sync with the animation. Our basic types, yada yada yada. Excuse me real quick, I'm gonna have to my nephew's got me sick over the past week, so I'm still coming down from that cold, so sorry about that. So the real code here is this spawn new minion class, or not class, but our spawn new minion method, which handles, we basically just pass in a type, it goes and it gives us an instantiates a new version of that minion, and then just basic default, returns it back out after he's after he's done it. This deactivates. This shoot method is just tying into the animation for the shaman for when he sticks his arm out and everything, so that we can handle that timing for the animation effects. So the thing that I really want to cover here is this method right here of our spawn new minion is very much, like I said, it's in line with everything. Our shaman shouldn't actually need to know about how to create an object. Yes, he is creating objects, but he has so many other things to be handling, like the animation and toggling the visual effects. Like, those are very much things that he needs to be aware of. Whereas he doesn't really need to know how an object gets created in the backend. That's just too many things for him to take care of. So this is, and then if we wanted to, not to mention, if we wanted to reuse this code somewhere else, there's no way to do it. The only option we have for this code right now is to copy and paste it into another class. And so if we had our level creator, our level generator, when it creates its minions, will have an exact duplicate of this information, but which then just starts to offer, you can already see the headache happening of, okay, well, we have a ranged melee magic. Now let's say we wanted to make, a tank class, or a very specific type, or some type of melee magic hybrid. So now you can already see with the number of places that code has to change is stacking up and stacking up and stacking up. So what we're going to do instead is we're going to take this code and we're going to centralize it using a factory. Specifically, we'll start with a simple factory. So that way, whenever the level needs an object, or needs an enemy to be spawned, or the shaman needs an enemy to spawn, we have one place that we can call it. We can just get that object from it, and then we can do what we want with that object. So the first step here is going to be to completely just gut this method call out of it. I'm going to cut it. We will go into our code and open up and create a new script. Let's call this the Goblin Enemy Factory. I'm going to go ahead and add a namespace to it. If you don't know how namespaces work, it basically takes all of your codes and it works same way as I believe Java packages. Puts all of your codes and all of your classes within a compiled group. It's a great habit to get into if you haven't done it, if you or haven't experienced with it yet, or haven't started implementing that into your flow. I highly recommend it. So we will, now that we've created our class here and our factory, we're going to go ahead and we're going to bring in the code that we had from our shaman class, which we will be missing references to these prefabs. So let's go ahead and grab those. These references right here. And then we will have our, we can technically, this is a use case to decide how you want to do things. You can technically leave these strings here where they are if you wanted to specify like the shaman can only create these certain objects. But what I would add when you, so in the simple factory idea, that works well. When we get to the, when we abstract it back out to the factory method pattern, you can start to, you can see how the factories that we create, you could simply just create a shaman factory. You know, a factory specifically for the shaman, so that way you can express the guidelines of this is the only one that, you know, this is all you can create. It's really just kind of up to you and how you want to handle things. I personally would, I'm personally going to move this over into the goblin enemy factory because it should know, in my opinion, that the factory should be the one that knows what types of objects they create. The shaman doesn't really care. And when we get to it, we can see how, when we replace it, you'll see how we can, if we wanted to give specific guidelines, the shaman to provide specific guidelines, we can do it that way. So we'll get rid of, since we no longer have this spawn new minion, we're going to get this one here and we'll say get minion from factory, because we're not quite there yet. We won't touch that code because that's for summoning. So in our factory here, we have all of these previous prefabs that we set on the shaman. If you want, you could make a prefab of this enemy factory and store it and just load that in if you wanted. What I'm actually going to do is make the factory pretty self-autonomous in maintaining. So rather than presetting these prefabs, we'll just load them up at runtime. So in this case, we would have private void start, and then I will grab this code real quick. Basically just loading in setting these values as we load them in from our resources folder inside of Unity. So we have these, now we have our spawn new minion method. So since and we have a cough again. Since our shaman no longer really cares what type of minion he's getting, we're going to go ahead and remove this string type and just randomly generate that string in here. So we'll say it's string type equals enemy types, and then we will just randomize across however many enemy types we have in this factory. So we'll say Unity engine dot random dot range and then 0 and enemy types dot length. Parentheses right there. So that'll randomly decide whether we get a melee, a ranged, or a magic person. Inside of this, we will say game object spawned minion equals null, because we're just specifically declaring that we don't expect this minion, this game object, to be anything at this point in time. When we go through, once we decide everything, switch case decides which enemy type to spawn. Default one, just to say, you know, if we provided a invalid value or an unexpected value, we're just going to go ahead and create a melee enemy. In this section, this is where you would handle anything of your equipped weapons, equipped armor, you know, set health stats, whatever type of code that, or whatever type of object initialization that you needed for this, in this case, our minions. So you'd put the rest of it in here just because, like, as I mentioned before, like this is our one central point for how objects get created. So that is we'd want to keep it here for that purpose. And then when we're done with all of it, we go ahead and return our spawned minion. In my case, we're just using game objects for simplicity. In reality, this would actually be, our product would actually be a minion subclass or an enemy subclass of something of that nature. But I wanted to keep it simple and just do game objects for now, just so it makes sense and can be applicable to more of a beginning style. So now that we have our goblin enemy factory, we will go back to our shaman. In our start, we will create a new reference to our goblin enemy factory. And say goblin factory. Inside of our start method, we'll say goblin factory equals, normally inside of other programs, you would just say new goblin enemy factory. That would be your basic constructor for that class. But since we are working inside of Unity, we're going to say add component. So game object.add component. And we're just going to add this to the shaman class itself. Or I should say the game object that the shaman class is on. Unity is not liking some of these, or didn't recompile from our previous error issue, so that's why we're not getting the syntax highlighting that we were before. But you can see our goblin factory here. I guess it's still a little issues with it. But now that we have our factory, we can take where we called our minion before, we can say spawn minion equals goblin factory dot create new minion, I believe, or is it summon new minion? One of the two. Spawn new minion. Not one of them at all. So our spawn new minion. So now we'll go take a look back. Everything should run. Start the game. Go back to our shaman. Have him spawn a new minion. You can see that we still are getting new minions from it. But this time, if we take a look at this shaman class, we've got our enemy factory here. He no longer has references to all of the other game objects that get created because he doesn't need that information anymore. He just needs to be worried about himself. So now our goblin enemy factory contains that information since it's the one concerned with how objects are created. So you can see that our goblin, our shaman is creating different goblin types. That works great, fantastic. So this is an example of our simple factory where we have our product, which is our enemy or our minion. We have our concrete factory, which is our enemy goblin factory. And then it creates a different, it has a different set of products that it can create from. In our case, we have 3, our ranged, melee, and magic minions. And then our shaman just asks the concrete factory, hey buddy, I need one of these from you. I'll let you decide which one it is. Just let me know what you end up making the decision on. So what we'll do now, and you'll see how it'll make it, you'll be able to get a little versatility in it, is if we convert to this factory method pattern. So the first step here is going to be looking back at our goblin enemy factory. We're going to encapsulate and pull out the information that would be consistent across multiple factories that create a new enemy class. And our class, like I said, is just the game object, but in reality, it would be an enemy class. So the first script we'll create is an enemy factory. This will end up being an abstract class because we don't want anything to necessarily inherit from this, or not inherit from this, but we don't want anything to implement the enemy factory specifically. We want them to implement or have a reference, or we want to implement versions of enemy factories, but we want all of our objects to only know that whatever version of enemy factory it is just enemy factory. So that we can get any type of things, whether it's so we can have a goblin factory or a skeleton factory or a lizardman factory, or in the case that I will demonstrate, we're actually going to have a dwarf factory. So in our game that we've had right now, it's been a dwarfs versus the goblins. But now the shaman's wised up, and he can actually spawn dwarves to go attack him now. or maybe you know, take it to another level, we have undead dwarves or something of that nature. So we'll clear out the Unity code. This will become an abstract class so that we can force everything to subclass from it. And inside of this, we're going to have, we're going to say that each of our subclasses have to implement this spawn new minion method. So in order to be an enemy factory, you have to spawn a minion. That is the rule that we're setting down. If you're not spawning a minion as an enemy factory, sorry, but you're not an enemy factory. So now that we have this one, in the case of our instance, we still want to have all of this. This is all very Goblin specific code for these sections right here and with our start. But what we'll end up doing in so in each our Goblin enemy factory, now that we've had it set up, that has its information. So what we'll do is we'll make this will subclass from that enemy factory itself. I didn't set this. Oh, so now that we we've declared our Goblin enemy factory as an enemy factory. So this is our Goblin factory, our enemy right here. So we've basically done this part where we said, okay, we are an enemy factory. We'll clear this out and we'll rewrite this for clarity. So this is actually our enemy factory. And this is our Goblin factory. So we've done this little section, this little arrow right here to say, okay, we are an enemy factory and we produce goblins. So we need to change this method right here, just override it since this is our version of the enemy factory spawn new minion method. So in the case of the Goblin factory, we're going to randomly select between which goblin we get. That's just what you get when you get the Goblin factory. So when we go back to our Shaman class, what we'll do here is rather than specifying, hey, I'm going to have a Goblin enemy factory, we'll just specify that we're going to use that abstract factory that we made, or that abstract class that we made that is an enemy factory. And then inside of this, we will refactor you for clarity to say this is an enemy factory and not a Goblin factory. So now our code effectively remains the same, and our start is a little bit different. So our start method still instantiates that Goblin enemy factory. So it's still specifying which one it wants, which is fine because we can go in then and say, we'll go back, we'll take a look at the game. Everything will still run as expected. So he summons a guy. We'll kill him because that's just the nature of things. So we'll kill the next one. So he's still spawning all of these guys. But what we can do now is say, we will go into our update method for, I've tied in this code here for spawning the minion. But what we can do is add in another one, and we'll say if input dot get key up, and we'll say keycode dot d for dwarf. We will say if we'll say enemy factory is equal to or equals get component dwarf factory. Oh, actually, I guess we need to create that class first. So let's go ahead and create our dwarf factory. For now, we'll call it an enemy factory, like I said, for clarity. So we'll have our dwarf enemy factory. This will be pretty straightforward implementation. Once Unity brings it up, it's on the wrong monitor, so let's bring it over here. So our dwarf enemy factory will implement the enemy factory subclass, which means that we have to implement a spawn new minion. But instead of this one will have a slightly different rules. What we'll do is we'll just give you a dwarf, a basic dwarf back. No need for any type of randomization. We only have one type of dwarf, so it'll be right here. So we'll just return instantiate a dwarf enemy. And before we get too far, this dwarf enemy needs a reference. So we will put it in start. We will say dwarf enemy prefab equals resources.load. We will look for it in our enemies folder, and then we'll say basic dwarf enemy. This right here, if you haven't, we need to specify it as a game object. So this right here basically is just saying grab this prefab information from this enemies folder, grab the one called the basic dwarf enemy. Let's see our errors. Okay, that's fine. So our enemy factory now, if we push the D key, is dwarf enemy factory. So since both dwarf enemy factory and goblin enemy factory both inherit from the same class, they become interchangeable on our shaman class. Here, so then we can implement, if you want a different factory, we can just say, hey, I want the goblin factory. So then we could even have a shaman that has, at runtime we can say, okay, you're the shaman that creates dwarves, you're the shaman that creates goblins. But our code stays exactly this, effectively exactly the same. We just create that type of information at runtime instead. So if we go here, I'm just basically looking for some cleanup, make sure we have everything set up properly. I believe we do. So if we push D and then push S, we'll actually get dwarf, or actually we need to do, if this is empty, sorry, if enemy factory is equal to null, we need to add enemy factory equals add component game object dot add component dwarf enemy factory. And just for clarity's sake and just to show that it's interchangeable, I'll copy this. We'll change the G for goblin, and then we would just say goblin enemy factory. Goblin enemy factory. Basically, if we grab the factory that exists on the player, if it doesn't exist, we add it, and then we set the value to that factory. So when we start the game, you'll see that the shaman class here will auto-generate our goblin enemy factory. So we'll press spawn, S for spawn, he'll spawn a goblin, we'll kill it. So now when I push D, you can see that we now have a dwarf enemy factory. So now when I push S, he's going to spawn it, but now we get this dwarf guy that comes out. So you can see that both of these are interchangeable. They're both only returning effectively an enemy, and both of the factories are in charge of create their own creation for what types of enemies they actually return. So now if I wanted to add, in our previous setup when we looked at our shaman, if we wanted to add a dwarf here, we would have had to have said, looking back at this was effectively our first code. So we would have had to then add like case, case dwarf equals this, but then let's say we had 3 different types of dwarfs. So then, let's say we had these 3 things, but they were all dwarves instead of goblins. So now all of this code has to then change to case goblin range, case make goblin melee, case goblin magic. So rather than doing that, we can just break those things apart from each other and let factories be in charge of what types of objects they get. So then when we want a dwarf person, we just say, okay, I want if we decide we want a dwarf ranged person, we just say, okay, I want dwarf, I want the dwarf factory, and then we tell the dwarf factory, I want a ranged one. Or, and then so, which then, if we added skeletons, let's say we want a skeleton melee, so we say we want skeleton factory, we tell them we want that one, we want a melee. Or if we just want any random skeleton, we just say, hey, skeleton factory, or random skeleton factory. If you wanted to break that up apart, you can say, hey, we could do that. But you can also then add your own, in your dwarf factory, anything of that nature, if you wanted to add in multiple, you could add in multiple different rule set for how those things get created, or you can make different factories with different rule sets. That's all a preference and a style thing for you, so that it's however you want that to work. So if we take a look, one last look at this, we have our factory method. We added our dwarf into this. Once I find where my cursor went, there we go. It apparently doesn't like the backside of that, so we'll just convert this to this. So this would be our dwarf factory. And then this one had made a certain product. This was just our basic dwarf. In reality, this one ended up making two other objects. So we can just do that, and we'll put one here just for space. And so this one actually ended up making this and this. But they all were treated as, they were all inherited. All of the products that were created were the same type of product. So now that our shaman class had a reference to our factory that creates this product, we can then make different factories, our dwarf and our goblin, that makes different products. But all in all, it all comes back full circle, and our shaman gets what he wants. So that, guys, is how a factory works. I know it's a little confusing at this point if you're just coming in, but that's how it goes. If you guys, I'll stop the recording, so that's fine. I'm going to stop the stream real quick and bring it back up so that it makes a good break point for me for when I cut this to upload it to YouTube later. So I'm going to stop the stream, come right back, and then I'll take any questions that you guys have. If